Data-focused Python homework 3 asks you to do a little bit of work with NumPy, the numerical Python module, and we did not have time during week 3 to look at the NumPy material in lecture. So I wanted to give you a tiny little bit of NumPy to just help you through what you need to know to do the homework, which is frankly not very much. To use NumPy, you say import NumPy, and almost always the abbreviation that people use for NumPy is NP. When you look at books making use of NumPy, they will almost always use this abbreviation NP, so we're going to go ahead and do that. It's a large module, so it does take a little bit of time to pull in. There we go. The primary data type that NumPy supports is something called an ND array, an n-dimensional array. Let me create A1 by calling np, whoops, I'll say A1 gets np.array. So array is a construction function for a NumPy ND array, in much the same way that you can use list as a construction function to create a list from an iterable, or tuple as a construction function, or set as a construction function. Here we're using array as a construction function, and the first argument here is going to be an iterable from which we're going to create this ND array. I'm not going to get into the details shown in this help message of what all these keyword arguments mean. I'm just going to create an example of an ND array by typing in a list of integers as my iterable. Okay, so that creates an ND array called an ND array object, and the variable A1 refers to that object. If I just ask to see what A1 looks like, it displays kind of similarly to a list, except that we have this prefix here, array, to give me a visual cue that this is an ND array rather than a list. I can access items within the ND array by subscripts. So A1 sub 0 is the 7. A1 sub minus 1 is the 1 at the end. I can do slicing. So A1 sub colon 3 is everything up to but not including the 9. That's item sub 3, so that's going to be an ND array just containing 7, 3, 12, and so forth. Now, the purpose of ND arrays is to give you vector-oriented arithmetic that is vastly faster than arithmetic that you can do with ordinary lists. The NumPy functions and facilities are all written in the C programming language, and they are designed to be extremely efficient for scalar and vector-oriented arithmetic. One limitation brought on by that is that the items within an ND array have to be the same data type. So here I was careful to make my ND array have all integer values. I could create another ND array to have all float values, let's say 2/3, 5/9, 1/2, 7/6, whatever. And here's a 2. And this ND array has 4 items in it, len of A2. Since ND arrays are iterable, I can use len on them to find out how many items they contain. All right. And I can use a for loop to step through the items in an ND array. So for, let's say, k in A1, print k, prints out the integers in A1. For x in A2, print x, prints out the float values in A2. All right, so A1, A2. Now, one of the nice things about NumPy is that it has a built-in collection of random number facilities. And these are found in a submodule of NumPy called random. So I can ask for, let's see, let me say z1 gets np.random.randn. This function, randn, returns to me random values generated from a standard normal distribution. A standard normal distribution is a normal distribution or a Gaussian distribution where the mean is 0 and the standard deviation, which is equal to the variance in this case, is 1. Okay, so mean of 0, standard deviation of 1. And since the standard deviation is the square root of the variance, that also implies that the variance is 1 as well. And so z1 here is one random number drawn from that distribution. I can draw another one, np.random.randn, and there's z2. All right. So this distribution is the so-called bell-shaped curve that you've undoubtedly seen somewhere along the way. I can specify to randn the number of values that I would like to draw from the random number, the standard normal distribution. So I could say something like zvec gets, or maybe z-array, I'll just say za, is np.random.randn. Let's get 100 values. Okay. So the len of za now is 100 values. Here is what it looks like. It's going to be large. Okay, it's quite large. And I can compute using a NumPy function, np.mean of za. And I get a value that's not, it's kind of close to 0. Not super close to 0, but it's kind of close to 0. And np.standard deviation of za is kind of close to 1. The larger your sample size is, assuming that this random number generator is of good quality, the larger your sample size is, the closer the mean of the sample should approach 0, and the closer the standard deviation of the sample should approach 1. All right, and so I think that those are enough hints to be able to help you get through the homework here. Okay, right, so we need to know about importing NumPy as NP, drawing values from the standard normal distribution. Now, part of this homework exercise asks you to define your own mean function. So you will need to define your own mean function and test it with samples drawn from the standard normal distribution. You can compare the result of your mean function with NumPy's mean function, and hopefully you should get the same result. We're also asking you in this homework to define a standard deviation function to compute the sample standard deviation. That will give you a slightly different result from the standard deviation that I got here, because the default NumPy standard deviation function computes what's called a population mean rather than a sample mean. You can, use Wikipedia or use Google to learn what the difference is between a sample standard deviation, which we're asking you to define, and the population standard deviation. Now NumPy, okay, and you cannot see the help message here, so that's not very helpful. But you can give a keyword parameter specifying the discrepancy from the degrees of freedom for the sample standard deviation. Basically, we would use a denominator of n minus 1 rather than n, and by saying DDOF equals 1, that's how we do it. And notice that the sample standard deviation is going to be a little bit larger than the population standard deviation. So your number should match, your number when you do the homework should match my sample standard deviation value that I got here. All right, now, part 4 of the homework asks you to read material in Wes McKinney's textbook about NumPy, and you are welcome to do that. You're welcome to try things out. Since we have not gone through the NumPy material in the lectures, though, this part of the homework will be optional. You can still get full credit for the homework by just not doing part 4. All right, well, I hope that that's a sufficient bit of NumPy to get you through this.